Okay, next we have a set theoretic characterization of sequences in X. So we will take sequences to be functions from n into X. This is particularly having in mind infinite sequences, although if we restricted the domain to just some natural number, then we could have a sequence of length n. But, just to see how this makes sense, take for instance the sequence of all squares of natural numbers, or at least positive natural numbers. We could regard this as being identical to the function f of x equal to x squared with domain n, or positive n, I guess if I wanted to be exact. Then, in order to emphasize that we are seeing this thing as a sequence, then we may use this angle bracket notation. And we can also have as our domain not just n, but possibly other ordinals like the transfinite ordinals, which I take to be, I don't think they were defined in the text, but I believe transfinite ordinals are ordinals that are strictly greater than n. We can use this notation that alpha sub psi, or xi or whatever, is an individual term in the sequence, right? And this will allow us to, maybe index things by the real numbers, for instance, which I'm sure at some point we will have reason to do. This sort of a sequence will be regarded as a sequence of length alpha, or an alpha sequence, and we say that this sequence is an enumeration of the range. So that here we have our definition of enumerating sets. We'll also define the notion of concatenating a sequence with some other sequence, or with some other term. We use this, this symbol here, whatever we want to call that, rainbow symbol? I don't know. Or we just write them next to each other. And this denotes concatenation, or that is to say that this produces an alpha plus 1 length sequence, where x is the alpha term in the sequence. Keep in mind that if we have an, say, length 5 sequence, then we're counting from 0, right? These sequences are 0 indexed if the viewer is familiar with programming, say in Python or Java. We count starting at 0 for totally independent reasons in that context, but we do traditionally count from 0, so that the first element is indexed at 0. And we similarly do so here. And that means that if it's length n, then the very last term of the sequence is the n minus 1th term of the sequence. So, okay. We can also talk about sequences of, indexed by all ordinals, and that would be this sequence itself would itself be a proper class. We could not regard that as a true set, although we could regard its range as a set. In any case, we will now start talking about transfinite recursion in the next video. It's associated with this theorem, which we will prove shortly.